Hey, hello there. This week I'll be practicing some problems on the topic of trie or prefix tree. So this review is going to be really short because I never learned this at school or from textbook. I never really used it in real life in any kind of meaningful shape or form. So my understanding about this is pretty basic. So to my understanding, it's a n-way tree. So the node can have a lot more children than your typical binary tree. So the primary use that I know is to store and facilitate the search of string value keys. So we insert a word inside this data structure. So next time when we want to search, do we have that word or do we have something that start do a partial prefix matching for the term? We can easily do that with this data structure. So yeah, so it's basically a n-way tree, and the nodes pass the pass of nodes inside this data structure is it's equal to a stringed key. So we have cat, cod, dog, door, ear, and eye. So the insert we can see is basically create the pass inside this data structure. How many characters we have in the word, how many nodes we need to either verify it's there or create a new node if necessary. So that's going to be linear with respect to the length of the word. For search, it's the same story. We just look inside this data structure key by key, character by character, and just check whether we have a termination node in the when the word ends. For the prefix search, it's a similar story. We just keep a traverse inside this data structure character by character. So that's pretty much all my understanding about it. As noted, as mentioned previously, the basic operations like add word, get word, do a prefix search starts with. They all take linear time with respect to the length of the search time. So we could either implement this as dynamically, like have this to be associated array hash maps, insert the node as necessary when we add word, or we can pre-allocate fix the size of slots corresponding to the size of the vocabulary. Depends on what can be more beneficial. So either it's pre-allocate the levels, all the childrens for the node, or we could do it more dynamically. So it depends on the usage. It could be the implementation could be different. Also, there might be some potential kind of compression we can do, but that's more advanced than what I know about it. So we're just gonna go through a really basic implementation about the trie. So each node we have an object for that, and it only has two slots: the children, which is going to be the character mapping to the actual node objects. So for the root node, it will have three different keys mapped to three different nodes. The character C will map to this particular node. So that's what the children's are. So it's a character to another trie nodes mapping. We could also have some other stuff stored on the node, either some particular data or a termination flag, meaning that this is the end of a physical word or something like that. So here I'm just having a Boolean flag. To initialize this trie data structure, we just create an empty root node. When we add a word, we basically go iterate over the characters in the word and just try to populate those node to character to node mappings inside this data structure. For search, either do the contain or starts with, we basically traverse through this data structure. So that's pretty much character by character. We try to follow the nodes path and return whether we have a termination flag or do we have a valid node. So after we return this traversal node, we can either we could either go about and query all the words that start with this prefix, or do something fancy, I guess. So yeah, that's really the basic implementation of this trie. I'm here to say what kind of questions can be solved using Trie beyond the basic implementations of it. So yeah, looking forward to solve some problems that use this. All right, so that's a really quick review about this topic. That's just largely due to my lack of experience with it. Yeah, I hope that I will add some sections down here after seeing some more questions about it. Yeah, that's pretty much it.